Welcome to our lesson on combining transformation of sinusoidal functions. Let's begin by drawing y equals sine x, which is our basic parent graph. So here is my y-axis, my x-axis. I'm going to label the x-axis in increments of pi over 2. All right, so for our sine x graph, we start at 0, 0, and then we're going to go up from there. We have a point at pi over 2, 1, come back down for 0 at x equals pi. Then at 3 pi over 2, negative 1, and then back to 2 pi. Going to connect our points. And then we can do the same thing on the other side. I already drew one period, but I can just draw another one just to get the full picture of our graph. So it's going to look something like that. So that's y equals sine x. In our last lesson, we looked at transformations one at a time on a sinusoidal function. But it is possible for us to draw a sinusoidal function that has 4 transformations on it. So here's an example. Y equals a half sine 2 of x minus pi over 4 minus 3. It is quite a lengthy job to draw a graph that has that many transformations, so I broke it down to 5 steps for us. Before we begin, I'm just going to draw our x and y axes. The reason why I'm drawing my x-axis so high is because I do need to shift everything down 3, and I need the room for that. Okay, so the first thing we're going to do is draw a new horizontal axis for the vertical shift. We're going down by 3. Usually our middle line is going to be on the x-axis, but because we're going down by 3, it's going to occur at negative 3. So I'm going to draw a dotted line to help us see the middle line of our sinusoidal function. Okay, the next step is to determine your starting point by looking at the horizontal shift. So for sine, we usually start at 0, 0. But instead, we had to go 3 down from 0, 0, so now it could occur at 0, negative 3. But we also need to move pi over 4 to the right because we have this negative pi over 4 here. So, but we're going to go 3 down and pi over 4 to the right. So that means our new starting point then is going to occur over here. So 3 down. I'm going to label this as pi over 4. So that would be our new starting point. Now we're going to determine the period of the function. Remember that period is 2 pi divided by frequency. Our frequency is 2, which is this number over here. So P is equal to 2 pi divided by 2, which is pi. So our period is pi. That means I need to start and finish one whole period within a length of pi. Step 4, determine your ending point by utilizing what we found for the period. So I'm going to continue to label our increments here. So if I started from 0 and I need to end by pi, we would have a length that looks like this, from there to there. But because I moved everything by pi over 4 to the right, now I'm going to start here and then end here instead, and that will give us a length of pi. So that means that my final point is going to be located over here because I need to start at the same y value, which is -3, and end at the same y value. But in terms of my x values, it needs to have a difference of pi. Now we finished step 4. Looking at step 5, draw the function and keep in mind about your amplitude. So our amplitude is a half, so I can't go more than -2. It has to be at -2.5 and -3.5. Okay, so it's going to look something like this then. That is one full period already. Remember, from the starting point, we have to go up and then down and then back for one full period. It's going to look something like that. You could draw more periods if you want to, but it's not necessary to draw more than one period. So let's do another example. We have y equals 2 sine of a half of x minus pi over 3 minus 1. I'm just going to get rid of this domain because it does complicate the question a little bit more. So I just want to make sure you can draw one period of that. It also says list the characteristics as well as the domain and range. Okay, so our first step is to find our middle line, which is going to be located at y equals -1. So that's our new midline here. Just drawing it dotted, just as a reference point for us. And then if you look at step 2, it says determine our starting point by looking at the horizontal shift. So our starting point would usually occur at 0, 0, but instead I have to go down 1 and also move pi over 3 to the right. So that's where my starting point is going to be, and I'm also have to label this as pi over 3. Then my increments have to be of pi over 3. So that's 2 pi over 3. This is full pi. And this is where 2 pi would occur. Same thing on the other side. This would be negative pi over 3, negative 2 pi over 3, negative pi, negative 2 pi. Okay, then our next step is to determine the period of the function. So our period is calculated as p equals 2 pi over frequency. Our frequency is a half in this case. Bring the half back to the top through multiplication. This gives us 4 pi. So our period is 4 pi. So that means from here to maybe up here is going to give us half of the period, or one part of it. And then I would have to go to the other side and get the other 2 pi. So from here to here, that's a length of 2 pi. Also from here to here is a length of 2 pi. So I'm going to end over here as well. Now, my starting point was this one. Then that means I had to go up and then meet at my end point there. So when I'm going up, my amplitude is 2, so it's to make sure that I go up and reach 1. So when I go down, I'm going to reach -3. So it's going to look something like this. for our graph. That is one full period. If you didn't want to draw the negative x values, you could have just drew it like this as well. And draw the full thing like that. Of course, you need to have the labels in there and say that this is one period where this is pi over 3 and this is just going to be after 4 pi. You could have done that as well. And that would have been correct. So for our characteristics, I'm gonna label the domain and range. So your domain is negative infinity to positive infinity. Your range is from -3. If you want to describe what transformations has occurred on this graph compared to its parent graph, you would say that we stretched vertically by 2. Our amplitude is 2. You'd also say stretched horizontally by 2, or compressed horizontally by 1/2. We moved pi over 3 to the right, and we also moved down 1. Our last example here, we're going to write an equation for a sinusoidal function that's already given to us. So I have the steps laid out here. It says determine the horizontal middle, and this will give you the vertical shift. Looks like our middle line is about here. Just by cutting it in half. So, and if we look at our value here, that's a -2. So that means we went down 2. Step 1 will give you information about the amplitude. So if we look at our middle line and count to our maximum or minimum, that will give us our amplitude. So that's 1. 1, 2, 3, 4. 1, 2, 3, 4. So our amplitude is clearly 4. Decide if we're going to use cosine or sine. Think of a reference point on the original sine or cosine graph and then compare it with this graph. How far left or right do we move? So I am just going to use sine because of the point on our y-axis. Usually the sine would start at 0, 0, but it looks like we just went down 2 and kept it from there. So I'm going to use sine. And I'll say did not shift. Look to see where this graph starts and ends without repeating. This will give you your period, which will help you determine the frequency. So we can just start at that red dot that I have as our starting point, and without repetition, it seems like it starts and then stops here without repetition. So that's from 0. Now to figure out what this value is, looks like we have 1, 2, 3, 4, 5, 6. We're going up by increments of pi over 6. So if that's pi over 6, that's 2 pi over 6, 3 pi over 6, 4 pi over 6. In other words, 4 pi over 6 would be 2 pi over 3. So that means our period is 2 pi over 3. If I want to find my frequency, that is 2 pi over our period, which is 2 pi over 3. Our frequency is 3. And we did not shift left and right, so we found all the transformations. We can put it all together. So our amplitude was 4. We used sine. Our frequency was 3. And then we went down 2. And that would be your final answer. You could have also tried to find another equation for this graph using cosine. And then it would be a comparable equation.